Okay, I'm going to do one more super quick video. This one's going to be on the cosine function from Gait Locomotion System. So there is two things, true speed, what is it called actually? It's called, there it is. There's two functions in the blueprint function library available for this specific thing. The first one is the cosine input, and you basically use this for human directional gait speeds. So if you're running forward, you're 100% forward. If you're running left or right, you're running 90% speed. And if you're running backwards, it's 70% speed. The upside to doing it this way with this pure function in the input action, so coming off your input action, which is just an input vector 2D that I just broke, is that when you do it this way, it actually prevents move hacks and bunny hopping, which can be really good if you don't want cheaters in your game. So this does require a separate Boolean here to check if you're using gamepad input versus keyboard input. And people ask me why all the time, is because a gamepad is an alpha of 0 to 1, whereas a keyboard is just 1. So it's functionally like different. We'll just say that. And at the end of the day, basically what this function is doing is it's creating a different shape to the input of your movement from an input axis perspective, which is really, really nice because, like I said, it can make it so that when you run backwards here, you run slower than if you were to run forwards, right? Or if you run left and right. And if you print your velocity, you'll see what I mean. That's the easiest way to do it. Just get your character movement component, and of course how you should do that, if you don't already know, get component by class. Use this all the time instead of casting. Casting is bad. You don't want that. Well, I shouldn't say casting is bad. C++ casting is all right because that's more of a conversion. Blueprint casting is more like a net, which you do not want. So in this instance, you have the GLS true speed as well, which is going to reverse the cosine movement function and return the just the straight up movement speed of the character. So if your movement speed is set to 600, for example, like default, it's going to return 600 even if you're only moving 70% of 600 because of this function. So it's a pretty specific use that you're not going to really have to use that a lot. Mostly what you're going to use is this. And unfortunately, there is no way around this. You do have to create two different inputs. So if you want gamepad and keyboard, you would have to have an IA move keyboard and an IA move gamepad, and then just select that Boolean. I don't think there's another easy way because there's no actual way to detect your move keyboard or gamepad if you're just reading it through the input action that I found. Like, you can't pull off of this and say, you know, if you're using this input device, it just doesn't work like that. So you do have to create two independently. Aside from that, all I'm doing is adding movement input to the controlled pawn. This is, of course, on the player controller because that's where you want your inputs to be. And then the world direction vector is just simply this. So we just get our control rotation, break that, make a rotator, and then do that. So pretty easy. That is the cosine movement function. I don't believe there's any more to it. No. Oh, so yeah, so there's a gamepad example right here. So I have the gamepad example and the keyboard example in this example project for Gait Locomotion System. And this will be available on the GitHub repository for any of the Patreons. Sweet. I hope that makes that a little bit more clear for whoever goes to use that function.